Hello, everyone. This is Belinda Kaur, and you're listening to my podcast on building science, products, and technology. As we know, the construction industry is ripe for automation and disruption. It has been reliant on manual labor and outdated tech for far too long, which has led to lagging productivity. Every week, I chat with a company that is exploring ways to tackle these issues. Today, I'm speaking with Ben Bogie, project manager at BPC Green Builders in Connecticut. Thanks for joining us, Ben.
My pleasure, Belinda. Happy to be here with you.
So, we crossed paths during our recent trip to Switzerland that was sponsored by SIGA. And I hadn't heard of you before. I hadn't heard of BPC Green Builders, but BPC Green Builders actually specializes in high performance, sustainable, and green homes. Y'all have built several passive houses, LEED Platinum certified homes, net zero energy homes, and even positive energy homes. Now, what why I asked you, and thank you for being on the podcast, of course, but why I asked you on was when I was listening to your descriptions of all the sites that we visited in Switzerland, it was very intriguing to me because you didn't talk about it just in terms of materials and construction and how things came together, but you were trying to decipher how it worked, how the materials worked together, whether it was the envelope, the assembly of the envelope, and then the overall building itself. You took it to a level beyond just a builder, and I found that very fascinating. And I'm sure the audience and myself is going to learn a lot from you during this podcast.
Well, I guess I can frame it as I was the child that would take apart the family VCR in the front yard to figure out how it worked and then hopefully figure out how to put it back together. So I've always been the type of person that I want to understand how things operate, and I want to kind of pursue things down the rabbit holes so that I can understand them on a core principle level. And if I'm able to understand things on kind of a core principle level, then I can do my work better. So if I understand how assemblies come together or buildings operate, then I can deliver a better built product for my client, or I can maintain my family's home to a higher level. So that's kind of my intellectual drive towards how I assess things. I want to go all the way down and understand how it's manufactured, how it's put together, how it was designed, what technologies it came from, so that I can try and apply my craft as best as possible.
That's fascinating. So that kind of mentality, usually kids with that ambition are encouraged to go down the path of being an engineer. I mean, at least from my experience. How did you get into the construction field and the building science field rather than an engineer?
Yeah, so I have kind of a rare distinction that I am a second or third generation high performance builder. So back in the late 70s, after the US oil embargoes, my grandfather became aware of the work that was happening in Canada around super insulation and what became passive building principles. So my grandfather and my father actually flew up to Canada to the Saskatchewan Resource Conservation House that Gus Handegord was built, or I'm sorry, I forget who it was that was actually building it off the top of my head, but the work that was being done in Canada at the time around building envelopes. So they kind of saw that this was an area that buildings naturally needed to go to. If we were looking at energy expenses and even community and national security from a resource dependence point of view, they saw that the industry was going to have to go this way. So they started researching this stuff in the late 70s, early 80s, and then built some super insulated, airtight, high performance buildings here in Connecticut, where I live, back in 1981 and 1982.
Oh my gosh. Before people were even talking about it.
Yeah. So when we look at kind of the arc of how an idea evolves, you have the pioneers, then you have the early adopters, and then you have mass adoption. They were definitely in that pioneering phase. So the work that they were doing at the time was monitored by the state utility companies and state energy regulatory commissions to explore it as a proof of concept. And they proved that it was effective and these building technologies made sense. But then the cost of energy dropped in the 80s, so everybody lost interest. But what that did is as a young man entering into my father's business, working in the trades, I was educated about air tightness and thermal bridging and insulation and air exchange and all these kind of principles that are now just kind of entering the real zeitgeist of the construction industry. But that was my everyday. For much of my early career, I took it for granted. I thought everybody knew this stuff. So that's kind of my genesis story into building science and high performance. At a certain point in my mid-20s, it went from being just a job to something that I saw as a career. And at that point, I really took a personal interest in exploring it further. And I took the foundation that my father and grandfather had built for me, and I kind of stepped on top of that and started doing my own research, and
Wow,
as
that's
charged as that term
fascinating.
is right now. Yeah.
And you actually ran your own high performance construction company a couple of years
Yeah.
ago for a while
Yes.
too.
Yeah, for about 10 years, I ran my own business, and I did a mix of things, from custom millwork and furniture work and cabinetry to building passive houses and doing energy retrofits. I kind of was the guy who would take on the projects that nobody else would take on, just because it goes back to my nature. I want to figure out how things work, how to put things together. So I would take on projects like a passive house retrofit.
And those sort of challenging projects, did they come to you from the client? Like the client had a desire to build a particular passive house and they couldn't find a builder that understood
It,
what it meant?
Yeah, it was a mix. So sometimes I'd be a referral from another builder or tradesperson that knew I would take something on, or I was the person that could probably answer the questions. The passive house retrofit that I did, that was 2015. It was the first certified EnerFit retrofit in the state of Connecticut at the time, and one of the first in the country. That came from a builder who had been approached about doing it, but it was outside of their service area, and they knew me, and it was a natural fit. And I
Oh,
love
wow.
problem solving. So
And since then, you have moved on to BPC Green Builders and you're using all your knowledge that you've gained during your own, while running your own company towards
yeah,
this new
well,
company.
yeah, there was about a 4 year period. So when my son was born, I decided I didn't want to do the 65-hour weeks anymore, and decided I was going to take a job. So I actually moved to Maine for about 4 years and worked for Dan Colbert up in Maine, who's one of the authors of the Pretty Good House book. That, if
Oh,
your
okay.
listeners aren't familiar with, is an
That's
excellent
been
resource that
circulating
just came
all
out.
over social media.
Yeah, so I had known Dan from Green Building Advisor and Northeast Sustainable Energy Alliance for a number of years, and went to work for him. And we produced, uh, near passive house level, reasonable construction in Maine for about 4 years together. And then about 2 years ago, moved back to Connecticut and took a job as a project manager for BPC because my body hurt from wearing a tool belt for 20 something years.
Oh, wow. So let's talk about our recent trip to Switzerland. We saw some pretty incredible high performance construction sites over there, and they were mainly multifamily. They don't have many standalone single family construction going on in Switzerland because land is so expensive and it's very difficult to it comes at a premium. So most of the construction sites, at least that's what we were told, are multifamily units. Um, did it surprise you to see the types of materials they used over there and how vastly different they are compared to the States? And maybe the building science
Yeah,
that they
I
adopt?
was anticipating it to be different, but I wasn't anticipating it to be like a complete paradigm shift, which it was for how I was envisioning what construction was over there. I was imagining that it was some kind of version of like light frame construction, like we do here in the U.S. in some level, but maybe with slightly different approaches. The biggest thing that I was struck by is as we were going through these buildings, which are were all being built to the Minergie standard, which is a rather rigorous building performance standard, actually more energy intensive than passive house. I was thinking that this is great. These are a curated trip of some of these high performance buildings, and we're seeing the best of the best in Switzerland. The thing that was a real kick in the pants was when I learned that Minergie is actually the
The
minimum
bare
code
minimum.
standard. That's the baseline that all buildings, residential, commercial, industrial, all have to comply with in Switzerland. That was a real
I had the
shocker.
same. Yeah, absolutely. I had the same reaction because I thought we were visiting the creme de la creme of all these
Yeah.
construction sites until I think we went to the factory, the Rengley
Yeah,
factory.
Rengley. Yeah, that's where I
Yeah.
realized it. That's one of their floor, their production manager. I was talking to him. I'm like, yeah, Minergy's great. I'm like, but how many people actually do it? He's like, everybody. We have no choice. This is our minimum. And there's actually levels above that Minergy standard for carbon and for site generation. And so they are building their de facto code is better than Passive House as a starting point. And when you
Kind of
ask them
puts us
about
to
it,
shame, doesn't it?
it's startling. And it's the thing that's even more shocking is you talk to them about it and they're like, it just makes, sense from financial end. You end up with a building that performs better and is easier to maintain the expenses of because they're quantified and low energy. And it also makes sense from a societal point of view because they're being resource efficient, they're not having to consume volatile energy markets, and it's just good stewardship in their eyes. So you talk to them about it and they're like, it's just, we don't understand why people don't do this.
Yeah,
And
let's
it's,
let's talk about that idea of resource efficiency. There was someone on the trip, I can't remember who, but I think Brian, he brought up a very interesting point and he asked you about this. Many of the homes and the construction sites we saw seemed like they had used an excessive amount of material, like
Mhm.
2 feet thick walls, 2 feet thick floors, ceilings. It was to an American that's used to stick building when and walls that are
Yeah,
mainly
three
built
and a
of two.
half, maybe 5.5
If you're
inches
lucky,
thick at most.
yeah.
Yeah, yeah.
It seemed like the amount of material that went into one site could have been used for an equivalent 3 or 4 units in the States. There was that much material that went into one particular unit, one particular
Yeah.
building. And someone on the trip brought up a point about front loading carbon. And they
Mhm.
asked you about this. And I thought that was
Mhm.
very, very insightful because, yes, it is resource efficient in terms of energy use over
Mhm.
over the life of the building. But what about the amount of energy that goes into building it upfront?
So that conversation is operational versus embodied
Yeah.
energy. Um, so this is an area where our industry is really just starting to dive in and kind of sink our teeth into what this means, and it's a question that's happening all over the place right now. And what we're seeing is that it's a balancing act. So the aha moment for me was about 10 years ago. I was at a Northeast Sustainable Energy Alliance conference, and I saw Jacob Reck-Houston from New Frameworks out of Vermont gave a discussion where they looked at the embodied carbon of a passive house building that they had just constructed. So the building was going to consume about 80% less energy, which is great. Operational energy was decreased, but when they looked at the embodied energy that went into it, it would take 150 years of that building's energy savings to offset the embodied energy that went into creating it. So
A
what that means
hundred
is
and fifty
in 50
years.
years to hit parity before
Oh
it was
my God.
doing any sort of environmental benefit. So what that means is in that 150 years, we can't modify it. We can't change anything on it. It has to be steady state 150 years before that building does anything for the environment. That was kind of the aha moment. And what they broke it down to is that it had a high reliance on plastic foam insulations, spray foamed insulations, steel, glass, plastics, concrete in order to achieve this particular building. Jacob has then gone on with Chris Magwood of the Endeavor Center and created this beam calculator and done a lot of really fabulous work on embodied carbon in buildings. And what we're finding out is if we're smart about our material choices, we can make buildings actually carbon parity at construction, or even buildings that store carbon at the time of construction. That being said, this question is something that we have to pay a lot of attention to right now, because if we're looking at what climate science tells us, that we have 20 or 30 years that we have to kind of start turning the tide back towards energy conservation. If we're front loading it by making all of these materials right now, we're actually speeding up climate change and putting ourselves into a worse situation. So it's kind of a scary thing to say, but there is a time where a high performance building that's using high embodied energy materials is worse than just a code built building for the environment. So
That's deep. That's
It's where we are right now. It's
yeah.
where we are. And it's the conversation that we need to be having.
So the buildings that we saw in Switzerland, they used a heavy amount of rock wool, which was surprising to me.
Yeah,
I mean,
mineral wool.
mineral
Rock wool
wool,
is a brand. Yeah,
yes, yeah, absolutely. Mineral wool, slag wool. We saw plenty of
Yeah.
fiberglass being used as well. And those aren't light on energy consumption. I mean, you just talked about foam, like closed cell foam or open cell foam. And from the conversations I've had with people in the foam industry, those are actually not energy intensive. Those are categorized as long-term use plastics that do not consume a lot of energy to produce.
That's
debatable.
That's debatable. So this is where
there's so much gray area in building science.
There really is. And so Joe Stiebrick has a comment that if we did our taxes the way we do carbon accounting, we'd all be in jail. Which is very true right now, because it's an area of the industry that's very much in the early phases, and we're figuring out what it all means. So the proof is in the EPDs, the environmental product declarations for a manufactured product, because those are going to show you the truth of what the impact of that product is throughout its entire life cycle. So my understanding, my knowledge of EPDs on insulation products is that plastic foams, closed cell spray foams, and extruded polystyrene still with the caveat of vacuum panels and aerogels sit still at the top of the chart for energy intensity as far as building materials go.
Just because of their recyclability issues, I guess.
Oh, no, because of the blowing agents that are used in order to manufacture them.
But they don't use any toxic blowing agents anymore.
That's not quite true, though.
It is.
So so no blowing agents anymore? They've gone to the HFOs.
None that emit CFCs or HCFCs. Those are completely banned. And again,
I understand. Yeah. I understand that. Yeah, they've gone to the HFO, the third generation blowing agents now, the hydrofluorinated olefins.
Yes.
Plural. Yes. Yeah. Which are much better than the HFC refrigerants that were used for those blowing agents, but they're still, we're talking carbon equivalents of 1,700 to 1 on a good side. So if there's 1 pound of CO2, they're equivalent, each pound of that refrigerant is equivalent to 1,700, and that's kind of the best case situations for the HFOs.
Okay.
And that's still not broad-based across the industry. Previously, they replaced HFC refrigerants that were somewhere in the area of 7,500 to 1 to 11 or 12,000 to 1. So they're better now. Okay. They're just,
but still not. Okay, I see what. Okay,
but then we start looking at things like cellulose insulation, which that's actually now carbon storing. So it's carbon negative from the time that it goes into the building, because it's a recycled content material. It's a natural fiber based material. So those can actually be carbon storing. Hemp materials can be carbon storing. Wood fiber isn't carbon storing
because it depends on where it's sourced.
Exactly. So right now, wood fiber insulations can be carbon storing if they only come from managed forestry practices. And unfortunately, that's not where most of them are coming from. So there is still some, but that being said, they are still a much better option than a lot of the plastic foams or mineral wools. Exactly. Some of these other things. So the whole game that we're discovering right now is we have to start looking at our product selections versus just the performance of the building. We know that we can make buildings that perform really well. We need to make buildings that perform really well without destroying the planet in the process of building.
So how do you, knowing all this stuff, because there are other people out there that don't dive into building science as deeply as you obviously have. So they might look to you as a resource and look to the best material that's available right now and use that for their particular project. But you, as a custom home builder that's looking into all these high performance homes, how do you balance? This is, like you said, it's a balancing act, because the science is constantly changing. You want to do what's best right now. How do you educate clients on this? Is it confusing to clients? Because one year you could tell them, yeah, this is the material you have to use. The next year with another client, you have to tell them something completely different because the science has changed and you've learned something new. How do you approach this whole thing as a builder?
We just have a totally honest and open conversation about it.
Okay.
And we just lay out exactly that, this is where we've come from and this is what we're learning. And as we understand it right now, these are the best choices we can make. And I don't want anybody to operate under the delusion that all I'm building is, wood fiber and hemp straw buildings. That's not. We still have clients that have real expectations for projects, and we have to meet the requirements of those projects for, budget, for aesthetic desires, for, buildability, availability, all of these things. So it's a constant balancing act. The biggest thing is, and I will continue to give them a shout out, is the beam calculator from the Endeavor Center, Chris Magwood. Having tools like that where we can quickly go in and essentially take our material takeoffs for our square footages of finishes and concrete and so on and so forth, plug those into this spreadsheet, and then toggle which materials we want to use, and it'll give us real numbers to make the comparative analysis. Like, is it better for me to use EPS here or to use closed cell spray foam, HFO spray foam here? And we can make those choices in real time very simply. So that's kind of the state of where we are as a practice right now.
And that's what I love about what Chris does. It's not black and white with him. He doesn't say it's one thing or nothing at all. You're doing everything wrong if you don't follow this particular method. Like with the calculator, like you just said, there are certain instances where if you balance budget and client expectations and everything else that you're like going through, XPS or EPS might be the right option at that particular moment for that particular project. And that's not a bad thing. It's just knowing that you're making conscious decisions and you're doing it for a particular reason. And at the end of the day, you're trying to do your best. That's all.
And it's really for us, the reason that's a game changer is it gives us a tool to be able to make those decisions very quickly. I did a complete beam model for a 6,000 square foot house in about 2 hours. For me to squeeze 2 hours out of my day to be able to throw some numbers in it and make some real world decisions about what the environmental impact is of my product choices, that's money well spent, time well spent.
Absolutely. So are there any lessons that you took away from the construction sites we saw in Switzerland that you want to use on any future projects in the States?
Yeah, whether or not I can because of product availability, that's another question, and also code compliance. The biggest thing that was interesting to me is seeing how vapor open their wall assemblies are.
Absolutely. Yeah, we didn't even see any vapor barriers being used on certain sites.
Which in a cold climate, that's great.
Yeah.
We shouldn't have any vapor barriers in a cold climate unless you're doing all exterior insulation. The one that really struck me was one of the multifamilies that we went to, where it was essentially like a 2x10 construction. The exterior of the building was rigid mineral wool insulation boards, which were tongue and grooved, and then a rain screen cavity outboard of that. There was no structural sheathing. There was no weather resistive barrier. My mind just exploded when I saw that. I'm like, how are they doing this? And the way they were doing it is they were handling the structure of the building, the lateral racking and resistance and the structural needs of the building, but in the core of the structure.
Yes.
Yeah.
So it wasn't relying on the exterior walls.
Those exterior walls had no real input as far as shear values or diaphragm strength or any of that goes. And then what that means is they can have this wall, which was gypsum board as an air barrier, the framing cavity full of mineral wool, and then this 2 inches of rigid mineral wool board on the outside. It's a total flow through assembly from a vapor perspective. The reason I like those assemblies is I'm from New England. We are surrounded by buildings that are 200, 250 years old. I cut my teeth in the beginning of my career is working in buildings like that. And the reason those buildings lasted so long is because they were able to dry out. Now, everybody says a building needs to breathe. A building doesn't need to breathe. A building needs to be able to dry. The reason those buildings lasted so long is because we would kiln dry them every winter by firing up the coal furnace or the oil boiler or the fireplaces or whatever, and they were dried out. So if we're trying to make buildings that have any chance of lasting 200 years, but we have so throttled the energy flow through them by reducing the thermal flow through them, the vapor flow through them, the air movement through them, we don't have those energy mechanisms to dry the assembly out anymore. We have to make assemblies that can dry just due to the nature of their construction very easily. And so what that means is we need assemblies that are very vapor open and can, if there's any vapor loading from cooking and bathing during the winter time, running that sauna or the fish tank in the house, and that gets into your wall assembly, or heaven forbid, we have a failure of a flashing, which will inevitably happen over the lifetime of the building at some point, and there's water in the assembly, it needs to be able to have a mechanism to dry out. And that's what they're doing. They're creating these assemblies that are airtight, but incredibly vapor open. So
do you see that sort of construction method eventually coming to the Northeast?
It's here. You just completed a project earlier this year that we used interior. It's on Green Building Advisor. If you search my name on greenbuildingadvisor.com, it was structural plywood on the inside of a 2x8 wall, 24 inches on center, and then 60 millimeters of Styco insulation on the outside and a rain screen cavity. So very similar to that Swiss assembly that we saw right there. So it's coming here. The area that we're seeing a lot of those assemblies right now is in panelized passive house projects, because that assembly lends itself very well to panelization. So that's Blueprint Robotics out of the Baltimore area, New Energy Works, Ted Benson, Benson Wood and Unity Homes. They're building those kinds of assemblies. So yeah, it's here and it's coming, but to see the level of adoption that it already has in Europe was
mind-blowing. Yeah.
Yeah.
Now, what about the quality of materials we use? Because that really stuck out to me too. The just going to your local hardware store, or even driving around any suburban construction site here in the States, or at least in Texas, it is the lowest of the lowest grade materials that they can possibly find. Yeah. And to go, and the sites that we saw in Switzerland, like completely straight, none of the members warped.
The framing materials, you could put your eye on a wall and you'd be amazed if there was a 32nd of an inch of bow in any single framing member.
Even the quality of the drywall, the gypsum board that they used was far superior to what we use here.
Yeah, and the install quality and just the level of craftsmanship that went in, it puts us to shame, really. Yeah. And it's a tough conversation because that's a cultural conversation that we have to have about what our expectations of quality are as a society. That's, granted, we didn't go out into the countryside and see the level of construction that was happening for a middle income farmer. That may be very different. I don't know. But my guess is that even that level of work in Switzerland is a higher degree than what we're doing here in the United States. It's a cultural question. They have an expectation that things are going to last for a very long time. They are willing to pay for things that are going to last a very long time. And the workforce is trained to a level that can deliver that. We saw it at one of the trade schools we went to. Those students are walking out of there with carpentry skills that even I, after 20 something years of taking on some complex projects, they were walking out of there with skills that I don't have. And that's day one at age 20. So that's pretty inspiring.
So you talked about the expectations and the cultural difference. So and it's not that I keep saying that we're being put to shame and we're doing things so bad over here, but you have been in this industry for a long time, and you have probably seen a definite improvement in the expectations of clients, like 10 years ago versus now. And people probably approach you knowing what a blower door test is, knowing what a passive house is, things that we weren't talking about in your father's generation or your grandfather's generation too.
Even the one that I keep talking about is from the whole pandemic situation. Ventilation. We have common people discussing ventilation rates right now. That used to be
carbon dioxide levels in homes too.
Yeah, that was something that was like siloed to us ventilation nerds at very like kind of niche building conferences where we could have those conversations, and now it's on the news. So the market is getting smarter here, which in turn is then going to drag the industry along with it, because if the market wants something, then the industry is going to have to supply it or figure out how to supply it. The other driving factor is for better or worse, depending on your views, code is pushing us to have to build better. I remember 15 years ago when I did my first job using exterior rigid insulation, the people at the local lumberyard looked at us like we had three heads. what are you doing? Why are you putting foam over the whole outside of the building? What a waste. But now in climate zone 5 and above, it's part of the IRC. It's part of the code. So codes are going to drag us there because, depending on your political viewpoint, it makes smart sense as a society to pay attention to energy consumption, because we look at all this volatility across the world geopolitically, or even just in US energy production, and the cost fluctuates so rapidly. If we can insulate ourselves by making buildings that are less tied to fluctuating energy costs, our society is more stable, because now we have less boom and bust cycles. So we're going to get there. And yeah, we do. Our clients come to us now. We have clients that come to us asking for passive houses, which is like, we're flooded with work. It's an embarrassment of riches at the moment, which is great to see.
Is there one particular project that stands out to you in your long career, like whether it was like particular hurdle that you overcame to achieve LEED Platinum or passive house status or even positive energy status?
Yeah, I think the one that I will look back on is the first passive house that I did. There's a funny saying that I heard from somebody recently: there's your first passive house and then there's all the rest, because that first one is like where the rubber really meets the road. You have to figure out how to make it work, because it's going to be checked and it's going to be tested and it's going to be verified. So for me, it was a passive house retrofit. We took a 1930s structure and upgraded with exterior eye joist, 12 inches of exterior insulation in an eye joist cavity, vapor open. We applied a 16-inch eye joist over roof to the building, vapor open, what's called a sarked roof. So it's essentially a rain screen on a roof.
What did you say that acronym was?
Sarking. So that's a common term that's used in Europe. It's the way they apply the battens with and perpendicular on top of the roof. So what it was is we had a roof deck, which was sheathed already. It was an existing roof deck. We stripped the roofing off of it, taped the seams on the roofing, put TJIs, wood eye joists on top of it, fastened those to the structure. Then we put a SIGA membrane, and it was my vest on that one. Over that, taped that. That was an airtight barrier at that point. Then 2x3s running parallel on the webs of the eye joists, or the flanges of the eye joists. Then 2x3s running perpendicular. And what that created was a 3-inch airspace above that airtight membrane that then the roofing, the structural roof deck went onto in the roofing. So it was a completely vapor open, airtight assembly for a roof. So it was a kind of a challenging assembly for a first passive house project, and still is kind of a challenging assembly. So that one was the milestone. And because it was a retrofit, we had to hit 0.4 ACH 50 instead of 0.6.
Oh dear.
Which on a 1930s structure as a retrofit was a challenge, but we hit it first time out of the gate after a little running around with some sealant and some can foam. But yeah.
Is that particular project highlighted on Green Builders website?
So that one's not on that one. If you go to protradecraft.com and search my name in there, there's a whole passive house retrofit series that we shot with them on that project, and some deep wall window flashing tutorials. And yeah, it's pretty well
I'm definitely going to look that up.
Yeah.
What do you think the role of do you think the role of a construction manager or people in the construction field is changing? They have to no longer just be builders. They need to take more responsibility on to be educators and be smart builders too.
The thing that I often say in this kind of discussion is in the late 90s, when I really started taking a paycheck in the industry, you could take a carpenter from anywhere in the country and plop them on a job site and they'd know what to do. It was 2x4s, 16 inches on center, with 1/2-inch plywood and Tyvek on the outside of it. You made the X cut and the Tyvek, you folded it into the opening, you stuck your windows in, and you nailed off the flanges, and that was it. So at that time, anybody could do it pretty much, and except for in the really high-end world. Nowadays, my job is spent as a project manager just shepherding information. So I am going between manufacturer's specs, architects' requirements, engineers' requirements, going back and forth between the installers, the trade partners, and just shepherding answers back and forth. So my whole day is just information management, which is something that we didn't have 20 years ago. So
in the past, like going through architecture school, we've always told about this idea of the master builder. The architect saw himself as a master builder 100 years ago. And to me, that the architect has fallen back. They have lost that role, the prestige. They have not kept
How,
up with
how much
changing
time did you
trends.
spend on a job site in architecture school?
Zero.
Yeah.
Zero communication. It was almost that we would, I hate to say this, but too arrogant to talk to the engineers, too arrogant to talk to the people on job sites. We knew better than them.
Yeah.
Now, diving into this whole field of building science, and I realize how little we know as architects, and it's a shame. I think building science needs to be integrated into architecture school. There needs to be more appreciation for builders, for people out on the job sites, for engineers. There's just, it's such a large, complex field. We
There can
cannot
be
be
no,
just be drafters anymore.
yeah, there
Don't
can be
don't
nobody at the table that's better than the other person, because especially when we're talking about delivering high performance buildings, especially high end high performance buildings, everybody has to sit at the table with equal footing. So we have to have the HVAC installer sitting at the table with the architect, with the
yes.
builder, with the engineer, with the manufacturer, and we all need to have this open dialogue and communication, and it has to continue through the entire project in order for it to be successful.
And things are getting so complex now. Every field is getting so highly specialized. We cannot be arrogant. There's no time. There's no room for arrogance anymore. We can't think of ourselves as just knowing everything there is to possibly know about design
It's
and
impossible.
performance.
It's impossible.
Yeah. So the more communication we can have with designers, with people in the MEP industry, with people in the construction industry, the better it is for the whole industry, as like the AEC industry as a whole. So,
and the thing
yeah.
that happens too is when you have that dialogue or that level of communication on a project, is you end up with people that are happier on the project.
Yeah.
Because they've had a chance to air their piece, instead of all of a sudden some person on high hands down this commandment that this is what they have to do, and in the real world it's a nightmare. If we give them a stake at the table and that installer can say, hey, you know, that's going to be really tough, I'm going to have to work on my back for days on end, can we do it this way? And we listen, and when we do it that way, then their job is that much smoother, which means that they're going to
Absolutely.
produce better work, and they're going to give us better pricing, and they're going to be happy to come back to our jobs.
Because there's such a big gap between theory and practice. That's exactly what you're talking about. I don't want to repeat what you're saying, but if architects sit in the office and say, this is the ideal wall assembly, according to these books that I researched, and according to the just theory, but then you go out on the job site and people say that it cannot be installed that way for very, very logical reasons.
The
So
classical one that I run into is like, the architects don't leave us anywhere to get ducts. Like, how am I going to get a return duct from the first floor to the third floor? Like, no walls stack. You guys don't want to see any soffits anywhere. Like, how am I going to do this? And
oh my gosh, this number of times
commonly.
people have said that. So just the other week, I had a podcast with this company called Misana. They make these radiant cooling systems.
Yes, we're looking at Misana panels right now.
And they said exactly what you just said. When architects forget to have soffits, that's when they call us up, when the builders and the engineers call us up.
So I was sitting with an architect about 2 weeks ago, and I said, one of the bonuses here, if we switch to a radiant cooling and heating panel, is you guys don't have to give me these big service cores now. So now I can just fish pipes through walls. I'm lucky that I exist in a rarefied era where we get to work with some very good architects that understand this, but that is not the norm across the industry.
That is not the norm. Yeah, that's a shame. But so what does the rest of the year have in store for you? It seems like you are one that wants to constantly learn, that's never satisfied with the knowledge that you have. And that's a wonderful thing. So what else do you want to learn? What do you want to do with your career?
So what I want to do with my career, that's like, what do I want to be when I grow up? I still haven't answered that question. This year, it's funny that you mentioned Masana, because one of my current things that I am endeavoring into is, for a long time in the high performance building world, we've used air-to-air heat pumps. Okay. So that has been kind of the de facto, because they have a high efficiency rate. The ugly little bugaboo with that is that they use high GWP refrigerants to operate, and they are very prone to leakage. I have more that have leaked over my career than I'd like to admit, and I have worked with very good installers. So that just tells me that there are a lot of them out there across the industry that are leaking. And what that means is that no matter how good and carbon mindful our building assembly is, if it's belching out pounds and pounds of refrigerant every year, potentially it's a problem. So what I'm looking at right now is the possibility of going to air to water heat pumps, which is not super common here in the US, because that does a couple of things. The air to water heat pumps are a packaged sealed unit. So the refrigerant is in a factory sealed condition in the unit and the water is fed to it, which means there's less likelihood of leaking. They use a much lower refrigerant charge. So there's, even if it does leak, it's a much less refrigerant that gets emitted. But also going back to water allows us to have the ability to do thermal storage. So it's funny, back in the 70s, there was this divergence from mass and glass passive principles to super insulated and airtight. And what seems to be
Mass
happening
and
right now,
glass to super
mass and
insulated.
glass. I gave a discussion about the history of high performance, and there was a break in the 70s when there was some houses that were being built in Massachusetts that proved that you didn't have to have, perfect solar orientation and mass inside the building to absorb that solar radiation into the building. You could just build a building that was well insulated and airtight and site it wherever you wanted, and it would function well. So at that point, that became the paradigm that most people in the world operated under. We did airtight and super insulated. But what we're finding now is that we're kind of starting to return back to some of these principles where we're using thermal storage or mass in buildings. Steve Brick floated something to us at IBS last year. He said one of the things he sees coming is people using like lightweight gypsum topping slabs in wood frame structures, because as we have a less reliable energy grid, that might dip in and out of function, and we may have blackouts or rolling power outages. If you have that thermal mass in a building, it will act as kind of a capacitor of thermal energy in the building, and the building will be able to ride out that grid insecurity, which was like an aha moment for me. We know this is stuff that's potentially happening with climate change and grid infrastructure issues. The thing that I like about moving to the air to water heat pumps is going to a hydronic system, because then we could go back to doing a couple of evacuated tubes on a building, and we can store heat in the wintertime into an insulated tank, or vice versa. In the summertime, when production is very high on our PV panels, we could run the air to water heat pump as a chiller and chill and store. Somebody said cool. We have the term warmth. So we store warmth, so we need to also store cool. We could chill water and store it in a tank, which can then be used to run through a radiant cooling panel to cool a building. And that energy is going to come when it's at the peak availability, lowest cost to us, lowest environmental impact during the summertime. So it's just starting to look at the paradigm of our energy usage and how we can harvest, wasted energy from building assemblies and put it into usable energy in other sections of the building assemblies. One of the ones that I heard recently is skyscrapers in New York City. There will be the north side of the building will be being heated, and the south side of the building will be being air conditioned at the same time. This is common in major cities all over the world.
It's happening right now.
I'm not going to say every building, but the vast majority of them right now. And that's because the solar exposure on the south is getting heated, and it's ejecting that heat via the air conditioning systems or the chillers up on the roof. And then you have a heating system, which is then burning fuels or whatever in order to heat the north side of the building. So what they're realizing right now, and there's big money that's getting put into this in New York City right now because it makes financial sense, they're just going to take that heat that's coming off of the air conditioning system that's being shunted from the compressors and use that as the heating. Like, what a no-brainer, but nobody thought of this. So it's just the paradigm of realizing that we have all these energy sources and abilities
someone
to
should tell them about
those
exterior. I'm sorry, I didn't mean to interrupt you, but
no,
someone
not
should
at
tell
all.
them about those exterior solar shades that we saw all across the entire country in Switzerland. That'd be another
the fact that they were
moment.
automated. Oh my God. What a no-brainer.
So many no-brainers, like you said.
Yeah.
Well, gosh, Ben, it's been awesome talking to you. You are a wealth of knowledge. We could talk for another hour about building science. Easily. It might bore some people, but I found this extremely educational, extremely fascinating.
Thank you, Belinda. It was my pleasure to be here, and I really admire the work you're doing. And
thank you.
Keep it up.
I definitely want to look into more of your projects. What's the best way for myself and everyone else to learn more about?
So
building
my
science?
current projects, I do a lot of work with Green Building Advisor and Fine Home Building Magazine. So my current project is being spotlighted on Green Building Advisor. There's a whole video series there talking about this single family residence that we're building, and we're trying to be mindful of the carbon impact on the building and trying to use best practices. So there's good info there. I do a lot of teaching in the industry. I'll be teaching at the International Builders Show in the High Performance Building Zone. I teach at JLC Live in the spring times, Midwest Building Science Symposium. Best thing to do is follow me on Instagram, Ben Bogie on Instagram, and you'll find me there.
You're a busy guy. You're a very, very busy guy. And I really appreciate that. You're not only on a quest to learn as much as you possibly can about building science, but you want to share it.
I want to have the conversation.
You want to have the conversation with everyone.
Yeah.
And just because then again, it's a cycle, right? You learn something, you teach it to someone else teaches you something, and it just keeps going on.
The thing I constantly say is these teaching environments that I put myself into, I learn more than the students that come to learn from me, because somebody will ask a question, or I am forced to have to stay on top of my game because I want to make sure that I'm giving people good information. So I get more out of it than they do out of me. So yeah, it's a give and take, and it's great.
Yeah, well, thank you once again, Ben. I really appreciate it and hope to have you once again, maybe sometime in the future, back on the podcast.
Anytime.